Hello students, let us try to understand the hydration enthalpy. Okay, so here the topic is the enthalpy of hydration of an anhydrous compound. So what do we mean by the hydration enthalpy, student? Let us see actually the enthalpy change accompanying the hydration of 1 mole of an anhydrous salt by combining with a specific number of moles of water to form the hydrated salt. So when the anhydrous salt is getting added to the water, it forms the hydrous salt. Okay. In that process, there is energy released, student. That energy released is known as hydration enthalpy. For example, student, copper sulfate is there. Okay, solid. It dissolve in the water. 5 moles of water. So it is giving CuSO4.5H2O, and that is at the same process there is energy release. 78.2 kilojoule per mole. So this is what the hydration enthalpy. Hydration enthalpy is always exothermic, and what is the formula? Mathematically, that is hydration enthalpy is the delta SH anhydrous salt minus delta SH hydrated salt. That is what the formula. Okay, student. So that is always it is negative. Okay, let us solve one problem, student, for better understanding. See, calculate the enthalpy of hydration. Okay, of anhydrous copper sulfate into hydrated copper sulfate. So we are having the copper sulfate, student, and we have to convert into hydrated Cu copper sulfate, CuSO4.5H2O. In that case, they are asking delta H hydration. Okay, delta H hydration. Given that the enthalpy of solution of anhydrous copper sulfate and hydrated copper sulfate are okay, they have given the anhydrous. They have given anhydrous copper sulfate minus 66.5 and hydrated copper sulfate plus 11.7 kilojoule per mole respectively. Okay, now see, student, it is the two-step process, student. Firstly, anhydrous copper sulfate. Okay, solution of anhydrous copper sulfate. So CuSO4 is there, student. It is dissolving in the large amount of water. This is solid and it is giving what? CuSO4 aqueous, right, student? And second step, and for that one enthalpy they have given minus 66.5. Okay, and this is the in the term of kilojoule per mole. Next one is there, that is copper sulfate. Okay, hydrated copper sulfate. Hydrated copper sulfate is there. Okay, and enthalpy of formation of solution of anhydrous copper sulfate and hydrated copper sulfate means that is copper sulfate CuSO4 dot 5H2O is forming, and how much energy is being absorbed here? 11.7 kilojoule per mole, right, student? And that is okay, and here is the step is there, that is CuSO4 dot 5H2O. This is there, and it is no plus 5H2O, so it is converting into CuSO4 and dot 5H2O. So in this process, student, actually the second step is not the actually correct step what we have wrote here. Wait, second step again, read out, student. Second step, they are saying that is solution of the anhydrous copper sulfate, that is a solution of anhydrous copper sulfate for this one, and hydrated copper sulfate. Hydrated copper sulfate are there, student, that is CuSO4 aqueous is there. Okay, CuSO4 aqueous is there. Hydrated sulfur copper sulfate, either you can write that is hydrated means CuSO4.5H2O is there. It is converting. Okay, it is converting. In what it is converting, student, you see, hydrated copper sulfate, that is CuSO4.5H2O, is converting into what, student? You can write that is CuSO4, it will convert, and plus what it will give, student? Aqueous, and plus it will give, student, uh, 5 mole of water, right? It will give. So that we have to understand, and here is energy they are saying, that is energy is plus 11 point, how much is there, student? You can see here, plus 11.7, plus 11.7, this is there, student. Okay, so in this process what we can do, student, that we need to understand the questions. Okay. So our required reaction is, what is required reaction? Required reaction. First of all, we should know that is required reaction. Okay. So required reaction, they are asking, that is calculate the enthalpy of hydration of anhydrous copper sulfate. So that is enthalpy of hydration means CuSO4. Okay. This is the aqueous plus 5H2O. It is giving what, student? CuSO4 dot 5H2O. Right. So this is required. How can you get, student? Okay, you use reverse this equation number 2. This is equation number 1, and this is the equation number 2. Okay, reverse the equation number 2, because this is required right side and it is given left side, and then add it out. So we are having, that is first equation, that is CuSO4 plus, this is the aqueous and here is solid. It is converting into what? That is CuSO4 aqueous. And in the second step we are having, that is again I am talking about, that is we are reversing this equation, student. So okay, here the value is minus 66.5, and this, if you are after reversing the equation number second, how can we write, student, after the reversing the equation number second? So CuSO4, this will be the aqueous, is converting into CuSO4 dot 5H2O. Okay, dot 5H2O. Okay, student. So what we can do here, you can now, after reversing the sign of this value will also revert, that is negative 11.7. So you will find that is CuSO4 this. Okay. No, this is the okay, no problem here. Why don't change this CuSO4? CuSO4, this is solid. So this is this CuSO4 is showing, this CuSO4 aqueous and CuSO4 aqueous you subtract. Then you will find, that is what you is coming, student, CuSO4 solid plus aqueous is there. It is giving, right, that is CuSO4 dot 5H2O. So enthalpy of hydration, hydration, you add it out. So if you are adding, that is both the equation you add out, that is 66.5 plus in bracket 11.7. So after adding, how much it's coming, student? That is minus 66.5 minus 11.7. So both you are adding, that it is coming minus 78.2 kilojoule per mole. Okay, so delta H, this is the hydration. So this is our required answer. Thank you so much for watching, friends.